I just want to go through how to do this in this video. And then in the second one, I'm going to show you how to use the graphing calculator to make this really pop. So up to this point, I have not, you could do everything without a graphing calculator. Let me just show you what synthetic division is all about. Now, this very first problem, f of x equals x to the fourth minus x cubed minus 12x squared, is not a synthetic division problem. But I want to compare it so that you understand why synthetic division actually exists. So here we go. This one actually springboards right off of the last lesson. This is a polynomial function. It is in pre-factored form. So since it's in pre-factored form, I know its degree is whatever the highest power is. So it's degree 4, which means that's even, which means if I were to sketch this graph, its end behavior would be up on the right and left, since the highest powered thing is not negative. I would then want to figure out what this graph looks like based on its factors. So here we go. I would look at this and say, hey, there's a GCF. I could take this out. I'd get this to look like that. I would then say, let's break that thing up into two binomials. And what are we going to do? It looks like x plus 3, x minus 4 is the key to unlock that baby, and that is true. So if I were to factor this, I have a double root. That's a double, so it's going to bounce at the origin. I also know my y-intercept is going to be at the origin because of that. I will have an x-intercept at -3, and I'll have an x-intercept at 4. So here's the thing. If I wanted to have a rough sketch, what is this thing actually going to look like? Here we go. I know I got a bounce at the origin at -3. I have an x-intercept, 1, 2, 3, 4. I got an x-intercept. So here's the deal with this. I know it goes up on this side. Whoop, a little crooked. It goes up on this side. And in between here, it's going to go doink, it's going to bounce, and it's going to go over here. Now, like I said, without a calculus class, you're not going to know exactly how low these two dips are. But guess what? That's what you'll learn in calculus, so you're going to build right off of what I'm doing here. Long story short, this is review. This was the last lesson. But what I'm trying to get at is this. In order to know where a graph will intersect the x-axis, we have to break it down into its smallest components. Now, take a look at this one. So this guy is a synthetic division candidate because I can't pull out the GCF. They don't all have the same factors. So there's a different technique called synthetic division that we will use. There's a couple things that we have to do before we can use synthetic division. Number one, is it in descending order? Does it go from highest power to lowest power? And the answer for this one is yes. So highest power to low power? Yes. Are there any gaps? When I say gaps, I mean, are there missing powers? It starts with a max power here at 3. Then it goes 2. Then it goes 1. Then it goes none. Hey, it descends. Power, there's nothing missing. When I say something missing, I'm going to show you this example soon, so let me just show you. When I get to, whoop, did I pass? No, there it is. See this example? It starts with a 4th power. It goes to 2nd, then it goes 1st, then there's none. There's a power missing, the 3rd power is missing. So when we get to that one, that's what this is all about. Highest to lowest, yes. Is there any jump between the powers? No, there's no gaps. So here's what we do. This guy has a coefficient of 1. Well, here we go. It's miraculous. Watch this. I'm going to take down the coefficients. There's a 1, there's a -7, there's a +7, there's a 15. No mystery. Where did I get these numbers from? They're already there. They're right there. Now, I'm going to draw a line. I'm going to draw an arrow straight down. I'm going to bring down the first number. I'm going to put it there. I'm going to draw a backwards capital L. This is my shelf. I'm going to pick a shelf value. The shelf value that I am going to choose for this particular problem should be -1. It could be 3 or it could be 5. But I want to show you what it looks like when you pick the wrong number. Now, you might look at this just like every other kid in the world I've ever had to teach this to, and they go, how the heck am I going to, Believe me, by the time I go through the third one, you'll have this down. It's really easy to do. It's not super easy to understand at first, but that's why if you look, I have 3 days of this, part 1, part 2, part 3. So here we go. I'm going to use the number 1 as my shelf. Number 1, once again, I'm telling you, is not a good choice. But I want you to see what synthetic division is. Synthetic division is a process. Synthetic division is what I'm about to do. I am going to take this number here. Hang on. I'm going to take this number here, this shelf number. I'm going to multiply it by my first number. So I go 1 times 1. What do I get for an answer there? I write it right here. It's 1. Add down. What is -7 plus 1? It is -6. Multiply 1 times -6. -6. Add down, it's a 1. 1 times 1 is 1. Add down, I get 16. Now here's the deal. This is not what I want. I want the very last number to be a 0. If the very last number is a 0, then I win. Let's just put it that way. I'm a winner. Ding, ding, ding. Yay, I get a prize. So here's what I'm going to do. I'm going to erase all this junk because I don't want it here. I'm going to have to start over. Now, I'm going to go to a different color pen just to keep this. So I'm going to make this a -1 this time. -1. Did I still bring down the first number like here, right here? Sure I did. So I'm going to go -1 times 1, that's -1. Add down. -7 plus -1 is -8. All I'm doing is combining. -1 times -8, I'm going to multiply this times this now. -1 times -8 is 8. Add down, I get 15. -1 times 15 is -15. -1 times 15. Add down. What? Flavor. There it is. I got 0. That's what I was after. Now, you ready for this? This graph, this guy right here. When I draw this picture, it will have an x-intercept at -1. -1 is one of my x-intercepts. Trust me, it's so true. I'm not lying to you. But wait a minute. We should have, this is a third power polynomial. It's going to have some certain n behavior. Guess what? It's going to have 3 x-intercepts. The highest power tells you that. We need 2 more. This guy right here that we just found, that guy's one of our x-intercepts in our graph. Where are we going to find the other 2? We're going to find it right here in the remainder. That's why they call this synthetic division, because this thing right down at the bottom, these numbers, are called the remainder. So check this out. Here's what we do. If we start with a third power polynomial, and we already found one of the answers, or one of the x-intercepts, we only have 2 left. Oh. I know, it's mind-blowing. I just filled in the blanks. I went descending order, starting with x squared. Then I put an x. Then I didn't put an x. Look, I filled in all the blanks, and guess what I do here? This is what I do. I factor this. and I say x times x, I need a positive 15. Well, that's going to be a negative 3 times a negative 5 in this case, because I want this to... Oh. So, hey, guess what? X minus 3. When is this chunk going to be 0? I have another x-intercept. It's at 3. I have another x-intercept. It's at 5. So here's the deal. If I wanted to sketch this polynomial graph, I would say at 1, 2, 3, there's a 4, 5, there's a, over here, negative, there's a, it goes up on this side. And guess what? Guess what? That's a y-intercept. Guess where it is? Guess where that y-intercept is? It's at 15. Bam! Mind blower. I know. It's freaky cool how that works out. Anyway, let's just talk about this. There's a lot of information in this video, but don't panic. It's easy stuff. It's easy peasy. Let's just talk about the rhythm of what we're doing. We're looking here at a third power polynomial. This guy is degree 3. Sure he is. That means I should find 3 x-intercepts when I do my synthetic division. Now, what do I do to do synthetic division? I make sure it's from highest power to lowest. It is. I make sure there's no gaps. There are not. It goes 3 power, 2 power, 1 power, no power. I copy down the coefficients they gave me. I draw an arrow down. This is going to be the first guy I start with, 1. Why? Because that guy's a 1. I'm going to draw a backwards letter L. I call that my shelf number. Now, my shelf number for this one, for this particular problem, let me see, because I did this earlier. The shelf number that works here is 1. What happened in my last example? I tried 1, it didn't work, so I tried negative 1. So here's the thing. I'm going to try 1. 1's the easiest number to work with, because what's 1 times 1? Remember, I'm going to take this number, the shelf number, times the leading dude. So 1 times 1 is 1. I write it here. Add down, I get negative 3. So what do I do now? I do 1 times negative 3. 1 times negative 3 is negative 3. Add down, I get negative 18. 1 times negative 18 is negative 18. Add down, it's 0. Ding, ding, ding. I'm a winner. All right. Why it works, all the special tricks will be revealed as we go through. But I'm just trying to show you that synthetic division itself is really not difficult to do. It's multiplying and adding, and then you get to the end. I have an x-intercept at 1. This is a third degree polynomial, so I have 2 more to find. How do I find 2 more? Right here in my remainder, I put an x squared. I put an x. I don't put that. Oh, bam. Chaw. Let's factor this. Let's factor this up. It's going to factor. Does it always factor? No. But that's why I'm not going to get everything done in one lesson. Let's just look at the ones where it does factor. While I've been talking, maybe you have already discovered that that's probably how it's going to factor. Cha-ching. Set it equal to 0 in your mind. Remember, whenever you see something parenthetical in math, it means the opposite is going to be the dude you want. So that's a 6. And then set it equal to 0 in your mind. The opposite of that is going to be that. I have 3 x-intercepts. Yay. Now, here's the thing. Here is the dealio, yo. If I wanted to sketch this graph, I totally could. I totally could. Because I have, at x equals 1, a point of intersection. It looks like 2, 3, 4, 5, 6. I have a point of intersection. 1, 2, 3. That's negative 3. I have an intersection. It's degree 3, which means it's odd, which means it goes down on the left and up on the right. Down on the left and up on the right. These are all straight through occurrences. These are not bounces or twists. I know that looks like a twist. That's just me having a spaz attack trying to draw a straight, not a straight curve. That makes no sense. You know what I mean, okay? That's flava. That's just me being a spaz. If it were a test, I would have erased it and tried to do it much prettier. By the way, when you guys turn stuff in as a test question, oh my God, I still wobbled. Anyway, remember, it's your best work. It's your prettiest pictures, whatever. So anyway, synthetic division. Now here's the deal. Let's look at this next one. And I don't know if you noticed, I used y equals on that one. I'm using h of x. I'm using function notation. I used h of x for the hex of it. Hex, get it? Okay. Hey, I'm missing a third power. There is absolutely no third power in this problem. So that's what I do. Whenever there's a missing chunk of information, I fill in the blank with a 0. Yeah, it's a placeholder. There are no x thirds in this problem. Now here's the other thing that I'm going to let you in on. If it is a fourth power problem, I have to use synthetic division twice. If it was a fifth power problem, I'd have to use synthetic division 3 times. If it was a sixth power problem, I'd have to use synthetic division, you guessed it, 4 times. Now here's the thing, synthetic division, once you get the hang of it, it is not that horrible. It's not the worst thing you'll ever have to do in your life. But if you can do fourth power, I'm sure you could do fifth. If you could do fifth, you could do sixth. So the highest power I'm going to mess with is fourth power. I mean, really, that's what I'm going to do. So let's get this thing the way we need it. First off, it is in descending order except for the missing piece. Now, I would not require you to rewrite this and say, oh, let's write it in descending order. Let's include the missing term. I wouldn't do that to you. But I'm also going to clue you in on this. When I taught you guys how to graph a polynomial, it wasn't really because I need you to be able to sketch a bunch of polynomials for me. What I really need from you is to be able to look at a polynomial graph and understand why it looks the way it does. So technically, we're working backwards now. Here's what I really want you to do. I want you to be able to take this function, graph it on your calculator eventually, look at the picture on the calculator because it will reveal to you the x-intercepts. And then when you do synthetic division, you'll know exactly what numbers you should use for shelf numbers. My first 2 examples I made up so that 1 or -1 would work. In fact, on this one, I think I made it so that 1 would work. Let me double check. I got to look at the paper. Yes, 1's going to work. But you know what? I knew that in advance. You don't know that in advance. I'm just telling you. When you look at part B, when you look at the next video, you'll see how to determine what to start with. Here's the other thing. The grand scheme, what we're really looking to be able to do is not sketch graphs. It's to take a polynomial like this. I'm going to erase this for a second. And solve an equation like this. That's the object of the game. What we're working toward with this Unit 1 is to learn about how graphs behave and a little bit of what graphs are trying to tell us. So this guy right here is what the question's going to look like. It's going to say, solve the polynomial, I'm running out of room, polynomial equation. Solve it. So let's get solving. This equation should have 4 answers. The other problems I've already done only had 3 answers because their highest power was 3. This one's going to have 4 answers. How are we going to find them? We're going to use synthetic division for most of it. Let's do it. I start with the shelf number. 1 times 1, I get 1. Add down, I get 1. 1 times 1 again, and I get 1. Add down, it's negative 14. 1 times negative 14 is negative 14. Add down, negative 24. 1 times negative 24 is negative 24. Add down, that's 0. So guess what? I'm a winner. I already know one of my answers is 1. Now, here's the thing. That started as a 4th power problem. So technically, this next step would be this. This guy would be x third, x squared, x, no x, la la. You see that? Check that out. Pretty fly. Anyway, I'm going to erase all those. I'm going to get rid of all this stuff because I don't want it clouding up my judgment. Because what I'm really going to do is I'm going to draw another line here. I'm going to draw a downward arrow. I'm going to draw the number 1. I'm going to do a backwards L because I'm going to use synthetic division again if it's 3rd power. So I have another shelf number to choose. Now here's the thing. I could use 1 again. 1 might work. But it won't in this one because I already made up the example and I know that 1 won't work. So what do? You go, well, what's the next easiest number to work with? How about 2? Would 2 work? Maybe 2's the breakthrough we need. So I'm going to erase that, and I'm going to get a 2. But remember, I'm the guy who made up this example, so I know 2 doesn't work. How do I know 2 doesn't work? Well, if I did 1 times 2, and I wrote the answer, and I went all the way to the end, I'm not going to get a 0 out here if I use 2. I want it to be a 0. That means I'm a winner. So I'm going to use negative 2 because that was the number I rigged this one to work with. But what are we going to do when we don't know? Don't worry, that's what Part B is about. I just want you to see the mechanics of synthetic division today. So here we go. Negative 2 times 1, that's negative 2. Add down, you get negative 1. Negative 2 times negative 1, you get 2. Add down, it's negative 12. Negative 2 times negative 12 is 24. Add down 0. See, it's already there. What? Crazy. So I have another answer. X is equal to 1. X is equal to negative 2. And I have 2 more answers to fill in the blanks. And I will have solved this 4th degree polynomial equation. I started with 4th power. I found one of the answers. Then I went to 3rd power, found the other answers. So here's what I say always. Once you get this thing down to 2nd power, you own it. Because now I'm just going to take this and say x times x. That'll give me x squared. Ends in a minus. That means opposite signs. I'm going to go 3 times 4. What? Flavor. That's negative 3. That's 4. Here's my other 2 answers. Cha-ching. Winner. I solved it. Totally. That's the thing. So in this lesson, I wanted to point out how you do synthetic division. You get it in descending order. You fill in any gaps that might be there. You start with a shelf number. You do some multiplying and adding until you get a 0, and then you go, woohoo, I'm stoked, I got it right. If you have to, you do it twice. How do you know you're going to do it twice? Because it's a 4th power problem. And then when you get it down to 2nd power, you own it. I don't know if you guys remember this, but when I was a little kid, Mom always said, when you get your polynomial equation down to the 2nd power, you own it. And I never understood what my mom meant by that until now, or until later in life. But I think some of the things Mom tries to share with us are like that. So I want to look at one more. That's going to be in this format. That's going to be in our future. This is how things are going to look in our future. So it's the instructions are solve the polynomial equation. Well, to solve this equation, I need to set it equal to 0. See, they didn't give me any fancy f of x stuff or any y stuff. They just said x cubed equals 12x minus 16. So let's do this. We're going to move this over. We're going to take it away, move it to the other side. We're going to add it to the other side. We're going to get x cubed minus 12x plus 16. That's what we're going to do. What's it equal? It equals 0. Set a polynomial equation equal to 0 to solve it. Now, here's another thing. You'll notice I moved these two pieces to the other side instead of moving the other one. You want to make your life easy as possible, so always start with the highest powered thing positive. Highest power positive makes you a happy kid. That's a horrible happy face. Anyway, makes you a happy guy or gal. So let's do this. I need to fill in a blank, don't I? This looks like it's missing 0x squareds, right? There's no x squareds in this problem. So if I were to do this, I would say x cubed plus no x squareds minus 12x plus 16. Going to set that equal to 0. Let's synthetically divide this one. And once again, all I'm doing is taking down the coefficients. I'm going to do it backwards L, call it my shelf number. It's actually called the root. So, but shelf number, that's what I always call it. Let's see, what should we pick? Well, I haven't let you in on this yet, but it's going to come in part B. So I'm going to just plant the seed, go to part B. The very last number in the list is 16. What goes into 16? 1 goes into 16. 2 goes into 16. 4 goes into 16. So does 8. So does 16. So, also, you've noticed every time I do synthetic division, sometimes it's a positive number, sometimes it's a negative number. So here are my possible choices for the shelf. Where do they come from? This guy right here. My possible choices are positive or negative 1, positive and negative 2, positive or negative 4, etc. So I'm just going to make this shorter because I'm going to show you how to do this in the next video. I know for a fact if I want this to work out, 2 is the number I want. 2 is the number I want. So I'm going to use 2. But why'd you do? Because I know, and I'll show you in the next video how I know. 1 times 2 is 2. Add down, I get 2. 2 times 2 is 4. Add down, I get negative 8. 2 times negative 8 is negative 16. Ding, 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 I'm a winner. My first solution to this is a 2. I need 2 more answers. So I'm going to say x squared plus 2x minus 8 equals 0. I am going to factor this, and it looks like plus 4 minus 2 equals 0. Yeah, baby, that's it. So I got 2 for an answer. It looks like I'm going to get negative 4 for an answer, and I'm going to get another 2. Hey, guess what? I got the same answer twice. That's okay. It can happen. It totally can happen. In fact, what do we call that? We call that a double. A double. Whoa. If I were to graph this, guess what's going to happen at 2? Guess what? If I was going to graph this, 1, 2, I would have a bounce. I would have a bounce right there. So fresh. I would. No lie. Now, I'm not asking you to graph it. I'm not. I'm going to show you what we do with the graphing calculator in the very next video. But I think you have the rhythm of what you do with synthetic division. Now, here's the thing. I also know that you probably have some questions. Like, is this number here always going to be a 1? No, it's not. But the easiest ones to do start with 1. It doesn't mean the other ones are super duper difficult, but the easiest ones start with 1. So the first number in every single one of my examples, take a look. I brought down the 1. The first thing I brought down was a 1. I brought down a 1. This goes, so The other question you might have, and everybody seems to get this one, what if what's left over at the end doesn't really factor? We have other tricks up our sleeve. We do. But once we get it down to second power, we have a plethora of different techniques to solve it. So don't worry about it. We're going to whittle away at this little by little. But that is my introduction. How do you do synthetic division? You got the basics. You got the gist of it. We're going to expand on this a little bit each time. But part B of this video is going to be me taking out the graphing calculator. So the video is going to look a little bit different because I have to do it live with my camera so you can see my keystrokes on the calculator. The other thing is, I don't know if you have a TI-84 or a TI-83, so I'm going to make sure, in case you have an 83 or an older model calculator, I will be working in what's called classic mode, because the 83s only have the choice of classic mode. The original TI-84, if you happen to have one of those laying around, you're using it with your brother or sister's old calculator. So when we get to the next video, you'll notice the first thing I do is there's a button on your calculator that says mode. When you push that button, depending on which calculator you have, a TI-83 or the earliest TI-84s, you are permanently locked into what is called classic mode. But on the later TI-84s, on the later TI-84 models, you will have a choice. Sometimes it's at the very bottom of the screen, or sometimes you have to use the next feature at the bottom of the screen, but then you'll see the word classic. I think it's in block print. And you can highlight it with your side-to-side arrows, and you hit enter, and you'll be in classic mode. On the TI-84 after that, the newer ones, it's right on the front. When you hit the mode button, you'll see it. At the very top, you will have a choice between what is called math print, which is fine. I like math print. Or there's classic. Those are your two choices. Default for the newest calculators is math print will be highlighted. So you just use the side arrow on your little toggle thing there. Highlight classic and hit enter, and you'll be in classic mode. If you get stuck and you don't know what that means, you can always ask me during the Zoom. But I only do that because if somebody has an older version of the calculator, they don't have the choice of math print. So, part B is coming up, guys, and you'll see how I get these magical numbers to use in my shelf. Okay, bye-bye.